Hello everyone! Okay, so today this video is going to serve as a brief introduction to functions. So what is a function? I'm so glad you asked. So if we think of a function, right, ignoring the mathematical elements of it now, we think of a function in English. What is the definition of function in English? So I have here, according to the Oxford English Dictionary, over here, a function is an activity that is natural to or the purpose of a person or thing. So, for example, what is the function of an oven? Right? The function of an oven is to apply heat. Yeah, that's the function of an oven. So if I'm putting something into an oven, I'm applying heat to my input, and then my output, I'm getting a cooked product, right? So we could say my oven, I have some sort of input. Then what I'm doing is I'm applying heat to that input, and then I'm left with something cooked. So for example, with an oven, say I put in some cake batter, right? So cake batter. So if I apply heat to this cake batter, and I apply heat to it, what's going to happen? I am going to get out a cake. A proper good cake, right? So that is basically the function in like real world sense, you know? So like the function of a washing machine would be to apply warm water and detergent to clothes, yeah? And then your output would be wet, clean clothes, right? The function of a dryer would be you put wet clothes in, it spins them and dries them, and then your output is going to be dry clothes. So that is functions in kind of real world appliances and applications. But unfortunately, that is not what you're going to be doing in your exams. So we need to discuss functions in a mathematical sense. So while real world objects functions, like we're applying stuff like heat, like water, like cooling something down, mathematical functions are basically the same thing. We're applying a rule or we're applying something to my input. It just happens to be algebra, like mathematical operations, right? So for example here, the formal definition of a function is a mapping, right, of a given set of inputs to a single element from a set of possible outputs. So what that means by that is I can't have an input giving out two outputs. You know, like as I said, to go back to my oven example, I can't put in cake batter and then get out a cake and a pizza. That's weird. That's some Spy Kids stuff. You're too old for that. Too old, too young. You're too young to know what Spy Kids is. But you know what I mean? That's weird. So that means the function of my oven, like that's not a real thing. That makes no sense. So it's the same thing apply in maths, and we'll show you an example in a minute. So we can write functions three ways. So we can write them as f bracket x equals, and then a little algebraic expression for my input. So my x is my input here. So if I put an input into this function, what I'm doing is I'm substituting x into my ruling here. Alright, so I can write it as f of x, so f being the name of my function. So I could have a function called f, I could have a function called g, I could have a function called h, I, j, k, l, m, n, o, p, right? So that's what the f is for, it's just the name of my function. Bracket x, that's just my input, what my input is, and then equals, and then it's just an algebraic rule or ruling I just sub my input into, and that in turn gives me my output. So f of x is my output. F bracket x is my output, I should say. I can also write it as y equals a ruling or an algebraic rule or algebraic expression. And I also could write it as f colon x right arrow x squared plus 1. And you're like, what's that mean? So this is just mathematical notation. So if you see here, these little colon here, this colon here, that just means such that. Right? So I have a function f such that I have an input x being mapped to my mapped to this algebraic expression here, x squared plus 1. So let's answer some questions on it, because there's no point me telling you how to do it, right? Let's do an example together. So let's have a look here, exercise 1.1. State whether or not the following arrow diagram represents a function. So these arrow diagrams are a great way we use to illustrate functions. So the left hand side, so the left semicircle, the left oval I should say, semicircle, left oval, the left oval is the set of all my inputs. The right oval is the set of all my outputs, right? So does this represent a function? Now, they don't give me any actual numerical or algebraic answers here. It's just represented by dots. But if you look here at these dots, if you look at these inputs, yeah, I have an input on top here, and it's being mapped to 2 outputs. It's being mapped to 2 outputs. Can't do that. An input has to go to 1 output. Right? I can't have an input going to multiple outputs, right? Because that doesn't make sense. And you're going to see why it doesn't make sense algebraically in a second. But I can't have 1 input going to 2 outputs. Therefore, this is not a function, because 1 input maps to 2 outputs. That's it. So just thing to remember functions is an input has to map to 1 output only. And that's what classifies a function. So now, we can also then use algebra to find the set of inputs and outputs, right? I'm going to add an extra question here because I forgot to add it in here. I'm going to ask us to find f of x when it equals to 6. Okay, so answer these 3 questions. So consider the function f of x equals 2x plus 3. Answer the following questions. So part A, using the value, find the value of each of the following. So I need to find the value of f of 5. I need to find the value of f of minus 5. And then I also need to find the value of f of x equals 6. So I need to find what my input value is that gives me an output of 6. So let's have to do this now. So f of 5. So f bracket 5. So remember, my function here is 2x plus 3. So what I'm doing is I'm 2 times my input plus 3. So f of 5 is going to equal to 2 times 5 is 10 plus 3. F of 5 equals 13. So therefore, for this function, if I have an input 5, I'm getting an output 13. An output of 13, I should say. The second one here, I. So I need to find f of minus 5. The same rules apply. So f of minus 5. So I am going to have 2 times minus 5 plus 3. F of minus 5 equals minus 10 plus 3. F of minus 5 equals minus 7. So therefore, when my input is minus 5, my output is going to be negative 7. And then finally as well, so if you look here, I have f of x equals 6. They want me now to find, if my output is 6, what is my input? So I have f of x equals 6. Now if you recall up here, f of x is equal to 2x plus 3. That's my algebraic rule. So now I just do 2x plus 3 is equal to 6. And now I have a simple algebraic expression that I'm able to solve for here. So 2x plus 3, so bring the 3 over. So I'm left with 2x is equal to 6 minus 3. 2x is equal to 3. X is going to be equal to 3 divided by 2, which is 3 over 2. So when my input is 3 over 2, or 1.5, my output is 6. Now, while I have numeric terms in there, I could also be asked to do this with algebraic terms. So if we look at this example here, express each of the following in terms of q. So f of q. So just to remember here, f of x equals 2x plus 3. So f of q then is going to equal to, so wherever I have x, I'm putting q. So I'm going to have 2 times q plus 3. F of q is going to equal 2q plus 3. And I can't simplify that anymore. So therefore, that is actually my answer. F of q is equal to 2q plus 3. And here as well, f of q minus 4. So f of q minus 4. So wherever I have x, I'm putting in q minus 4. So I have 2 times q minus 4 plus 3. Distribute property, I'm going to be left with 2q minus 2 times minus 4 is minus 8 plus 3, which is equal to 2q minus 5. So f of q minus 4 is equal to 2q minus 5. And they are my solutions there. Let me highlight these now, if it will let me. No, not let me highlight? Okay, you get the point. There's my answers there. Okay, so next part in this introduction is the domain, codomain, and range. So these are a few terms you need to be familiar with. So the domain is the set of all inputs of a function, right? In my next video, I'm going to be going over graphing a function, and you're going to be given a set of inputs that you need to put into this function. So that's called the domain. The domain is the set of the input values. The codomain is the set of all the possible outputs of a function. So it's the set of all the possible outputs. And then the range is the set of actual outputs we received from the function. So this seems to confuse a lot of people. It seems to be a lot of confusion between codomain and range. So let's look at an example, yeah? So these people are ordering from a restaurant, right? So we have John, Mark, and I don't know, Sean, right? So they're ordering from a restaurant. Their order is going to be our domain. The customers are the domain here. They're ordering from a menu. The codomain is my menu, right? They could get anything. They possibly could get a latte, hot chocolate, espresso, Coca-Cola, and an orange juice. They have, that's all the possible things they get. But in actuality, John chooses a cappuccino, Mark chooses the Americano, and Sean chooses the Diet Coke, right? And then since they're my set of actual outputs, that is known as the range. She doesn't have the range that way. She doesn't have the range. It's the range. Yeah? So let's look at an example here. So the arrow diagram represents the function x squared minus 2. Part A, list all the elements in the domain. So remember, my left oval is the set of inputs, or my domain. So that is going to be equal to 2 minus 2, 3 minus 3. That's the set of my inputs. List the elements in the range. So the range is the set of actual outputs I received. So if you see here, all my arrows either point to 2. So 2 is a part of my range, and 7. And 7 is a part of my range. So 2 and 7 are my range. They are the actual outputs I received. Part 3, list the set of elements in the codomain. So that is all the elements in the circle. So 2 and 7 were actually chosen, but 8 was also a possibility there. So that means my codomain is going to equal to 2, 7, and 8. And then finally, write the function down as a set of couples. So a couple is just a coordinate point, basically, right, of my input and my output, right? So x and y, right? So, for example here, 2 maps to 2, so therefore my couple is 2, 2. So when I have an input of 2, I received an output of 2. My next set of couple is going to be -2 to 2, because -2 maps to 2. 3 maps to 7, and -3, 7, right? And there are the set of couples that I receive from this arrow diagram. Right, so I hope this kind of helped. So this is just an introduction to functions, and in my next video I'm going to be going over how to graph said functions. Right, hope you enjoyed, and I'll catch you on the flip side. Peace.